Hi everyone, in today's video we're talking about Microsoft 365 Copilot, Copilot Studio. Moreover, we'll also learn about what are large language models and how they can work with your organizational data. Recently, in one of the business meetings, I was listening to a business leader talk about this as an IT department tool. If you're a business leader looking to take your organization forward, these AI capabilities can bring a lot more than just productivity. You can drive by the data, large amounts of data. So if you're someone who's looking to move forward in this AI-driven world, this is a great tool, and this video will help you understand all about Microsoft 365 Copilot. So I've divided this video into 4 key parts. 1. Deep dive into Microsoft 365 Copilot. We'll explore what Copilot is and what features it offers for your enterprise world. Second one, understanding the basics of AI. Let's get acquainted with foundational concepts of AI, including machine learning, deep learning, large language models, and other aspects. For the third one, we are looking at how can you extend this Copilot from the base Copilot that Microsoft offers you for your organizational needs. So how the plugins work, how the Microsoft Graph connectors work. And the fourth one, we'll talk about the importance of security for your enterprise data, what Microsoft has been added to this layer of Microsoft Security Copilot. Okay, let's jump into the Copilot system. Basically, an enterprise-ready AI from Microsoft. Let's start with what is Microsoft Copilot system. As we know, Microsoft is uniquely positioned to deliver enterprise-ready AI with their investment in OpenAI, ChatGPT. The name they have given to provide this AI at enterprise level with all their Microsoft 365 apps is called the Copilot system, which is the backbone of how Copilot works in almost all the Office apps. It's not a simple case of Microsoft slapping ChatGPT onto their Microsoft 365 suite. Copilot for Microsoft 365 is more than OpenAI's ChatGPT embedded into Microsoft 365. Copilot for Microsoft 365 works with 3 foundational technologies. 1. The Microsoft 365 apps. That's your Word, Excel, PowerPoint, Outlook, and more. The second one is Microsoft Graph. That's all your content and context, your emails, your files, your meetings, basically your security profile and your calendar and other aspects of it. The third one is large language models, or LLM, a creative engine capable of parsing and producing human-readable text, all accessible through natural language. So it all begins with a prompt in natural language from the user in an app like Outlook, Word, or other apps. Same as what you might have seen in ChatGPT or other AI tools. In the next section of Basics of AI, we'll get into details of how did AI evolve into understanding the natural language. Copilot, however, takes these prompts further through a process called grounding. Put simply, grounding improves the quality of the prompt by embedding some context like which user, app, and calls Microsoft Graph. We'll get deep into this grounding and Microsoft Graph again in the next section. This call to Graph retrieves your business content and context, such as emails, files, meeting chats, and calendar entries. Copilot combines this user-specific data with other inputs to refine the prompt further. This modified prompt is then sent to LLM. We will learn more about how LLMs work and what Microsoft has done to these LLMs to secure with your enterprise content in the next section. Once the processing in LLM is complete, Copilot takes the response from LLM and does the process called post-processing, where Microsoft has built this post-processing to include additional grounding calls, again to Microsoft Graph, responsible AI checks, security compliance, and privacy reviews. It also generates commands that enable seamless interaction with your apps, like text to Word, or format the response into templates like summary, or a presentation, or other formats like in your email and other things, which is where the Copilot is different from other stock AI models. Basically, this is a custom enterprise AI, or GPT, built by Microsoft for us to use right out of the box. This process is iterative and performed multiple times, if not hundreds of times per every call, to avoid security pitfalls, hallucinations, and other aspects. We'll talk about security and how you can extend the plugins and graph connectors in the next section after we understand how and what is AI. The goal here is hoping this section helps you get the basics and can expand more on each topic if you want on your own. Let's start with the broadest possible question. What is artificial intelligence? The easiest way to think of the artificial intelligence is in the context of humans. We know of AI is a broad branch of computer science. The goal of AI is to create systems that can function intelligently and independently like humans. Furthermore, we can divide AI into symbolic learning like computer vision, robotics, image processing. On the other side, as humans, we are very good at pattern recognition, but machines are even better because they can look at a lot more data in a lot more dimensions. And this field is called machine learning. Under machine learning, we also have statistical learning and deep learning. On the statistical learning side, we have speech recognition, natural language processing, because as humans, we speak and listen and communicate through language. Much of speech recognition is statistically based, hence it's called statistical learning. Okay, before we get to deep learning, let's look at few concepts like CNN, RNN, and NN, neural networks. So human brain is a network of neurons. We use these to learn things. If we can replicate the structure and the functions of human brain, we might be able to get the cognitive capabilities in machines. This is the field called neural networks. So if we look at CNN, to simplify, if we get a network to scan images from left to right or top to bottom, it's called convolutional neural network. And the next concept is RNN. Humans can remember past, like what we had for dinner yesterday night, last week. Sometimes I can. But if we can get the neural network to remember a limited past, this is called recurrent neural network. Basically chat history. Based on your chat history, it can give you the context answers. Now that we know neural networks, deep learning is essentially a neural network with 3 or more layers. These neural networks attempt to simulate the behavior of human brain. Although far from matching its ability, allowing it to learn from large amounts of data is the key aspect of deep learning. While neural network with a single layer can still make approximate predictions, additional hidden layers can help to optimize and refine for accuracy. Deep learning models can further be broken down into something called discriminative models and generative models. And to simply put, when we train these discriminative AI and generative AI on large sets of data, what we get is LLMs. Basically, LLMs could be composed of both Gen AI and discriminative AI. And this is where your ChatGPT, Google Bard, and others fall in place. Now that we have understanding of the overall landscape and you can see how different disciplines sit in relation to each other, let's go over some key takeaways. In a nutshell, machine learning is a program that uses input data to train a model. That trained model can then make predictions based on the data that it has never seen before. Let's say you got a bunch of sales data from Home Depot, and it's all from hurricane season in the past. Now imagine taking all that info into training an AI model. What you get is a smart AI trained model which can look at the patterns and make some pretty good predictions. You can take this model and use it for another company, let's say like Northern Tool or Lowe's or other companies. They can use this to predict their needs in the next hurricane season. We are talking about how many generators they should stock up and even figuring out the best prices to stay competitive. It is helping your inventory planning, making sure you're ready and are on point before the storm hits. So this is a great example of how a trained model on a different data can help with your data. Now that we know deep learning, let's divide machine learning further. Two of the most common types of machine learning models are supervised and unsupervised learning models. The key difference here is supervised models use labeled data and the unsupervised models use unlabeled data. Let's look at one of these examples. In this supervised example, let's take the example of these carrots, bell peppers, and tomatoes. Let's say 5% of this data is labeled. So we feed this labeled data into the model for training. Once the training is done, when we give the new test data, this model can actually predict which one is what. So as you can see, it can predict carrots, bell peppers, and tomatoes. But for unsupervised learning models, we can look at the raw data and see if it naturally falls into a group. In example below, we can see that the model with raw data is fed through an algorithm, and this algorithm actually puts them into clusters, the same clusters as carrots, bell peppers, and tomatoes. One of the big advantages of supervised models is that supervised learning models makes prediction, and it will compare that prediction to the training data used to train that model. If the gap between the prediction and the expected output is large, these supervised learning models can try to reduce their gap by adding more training data or adding these anomalies. Now that we have seen machine learning, let's dive into deep learning, where we can look at the cognitive capabilities using the artificial neural network. If we keep it simple, artificial neural networks are inspired by human brain and look something like these nodes. The more layers and nodes of neurons we have between input layer and the output layer, the powerful the model becomes, the deeper the model becomes. One of the advantages of these neural networks is something called semi-supervised learning, where a deep learning model is trained on small amount of labeled data and a large amount of unlabeled data can be processed. For example, a credit card company might be using deep learning models already to detect fraud. The company spends a bit of time and tag and give fraud score to at least 5% of their transactions as fraudulent or non-fraudulent. Then they leave the 95% of the other transaction data unlabeled, both to save time and resources, as it's nearly impossible to label every transaction. The magic happens when deep learning models use this 5% of labeled data to learn the basics concepts and the logics behind these fraudulent transactions. Then apply these learnings to 95% of your unlabeled data, which is live and updates every minute, sending alerts to the users and the company in real time. So before we get to Gen AI, let's look at another example of discriminative AI, which we might already use it in our phones. Let's say you have pictures of cats and dogs. If you label some of your pictures as cat, some of your pictures as dog, your phone is pretty capable of tagging them as cat, tagging them as dog. It can even do with persons. So the example here is if you have a picture of cats and dogs and you send it through a model, basically the output would be when you give a new photograph, let's say of a dog, it will predict the classification as a labeled dog, but it will never be able to create an image of a dog. That's where Gen AI comes in. So Gen AI, instead of looking at the labels, it looks for patterns, for data points that resemble a dog, that resemble a cat. So when we give a prompt to Gen AI, create an image of a dog, it looks for the patterns instead of the labels. And using those patterns, it's able to create an output of a dog. Here's how I learned to determine if something is Gen AI or not. If the output is a number, classification, probability, fraud or not fraud, it is not Gen AI. It is generative AI if the output is natural language like text, speech, or an image or an audio, then it is Gen AI. Basically, Gen AI creates new samples of data similar to the data that it was trained on. Moving on to other types of Gen AI, something like text-to-text like ChatGPT or Google Bard. Other common Gen AI models are something like Midjourney, DALL-E, which can create new images. And the other types of models are text-to-task models, which Microsoft is spending a lot of their energy into the Microsoft 365 apps. For example, if you type to summarize meeting notes or catch me up on your Outlook, Microsoft Copilot can do that for you on their apps. So basically, these are Gen AIs that are text-to-task. Now let's look at large language models. As we saw earlier, that LLMs are also a subset of deep learning. And although there is some overlap with LLMs and Gen AI, they are not exactly the same thing. Important distinction is that large language models are generally pre-trained with a large set of data and then fine-tuned for a specific purpose, which is what Microsoft Copilot is doing with their LLMs. And let's jump into the next topic. How can you extend Microsoft Copilot for Microsoft 365 for your organizational needs? On its own, Copilot for Microsoft 365 is a powerful productivity tool for keeping users in the flow of their work across Microsoft 365 applications. However, business workflows don't typically run exclusively on Microsoft 365 applications and data formats. With Copilot extensibility, you can augment Copilot for Microsoft 365 with custom skills and organizational knowledge specific to your enterprise. Let's look at plugin and connectors. I'll give examples for each after this explanation. You can extend Copilot skills by transforming your app into a plugin that increases users' productivity across daily tasks and other workflows. Also, you can enrich your organizational knowledge accessible to the Copilot by ingesting your enterprise data and connect with Microsoft Graph connectors. So let's get to these examples. You're a tech-savvy developer and you want to make most of your Microsoft Copilot's capabilities. Copilot is like having a coding companion already, but you can make this Copilot even smarter by creating a plugin. This means when you're coding in your favorite development environment, Copilot will jump in and offer suggestions, code snippets, and even context-aware insights specifically tailored to your project management tasks. Now let's jump into it. The importance of Copilot and security for the enterprise data. With great power comes great responsibility. Integrating AI into the enterprise system raises valid concerns about data security and privacy. As you can see, to keep the video short and make in detail videos for the below, here is what I have for this section. The first one is responsibility and ethics in AI. The second one is guidance for users. And third one is privacy and compliance related stuff. And the last one is innovation with security with Microsoft. So let's look at the first one, responsibility and ethics in AI. Microsoft has introduced key principles like fairness, inclusiveness, transparent compliance, standards for AI privacy, and security to address concerns about integrating AI into enterprise systems. But before we jump into more of it, let me talk a bit about grounding as promised long ago. So grounding is a way that Copilot gets enough information to answer questions accurately. As per Microsoft, it's a big part of how they limit their LLMs from hallucination. So what is AI hallucination? In the world of artificial intelligence, it's a fascinating phenomenon where machines, as we have learned before, particularly deep learning models, generate outputs that go beyond the scope of training data. So they don't need to have the exact answers and stuff. So this is where Microsoft has built strict guidance controls to control the Copilot system, and why we hear grounding a lot more instead of calling them as AI hallucinations. So here are a few things that we can talk about debunking some AI myths and Copilot's functionality. Like we spoke earlier, AI hallucinations, the first one. As we understood, the grounding process ensures Copilot's responses are accurate and less prone to AI generated errors or hallucinations. The second one is user proprietary data. We have learned through graphs, but Copilot enhances business value without using user data for AI model training, maintaining the privacy and compliancy. The third one is data protection. Leveraging Azure OpenAI services, Copilot upholds the robust security and standards that protect sensitive business information already from their OpenAI services as well as the Azure services. There are many courses for free. Here is a course that I have gone through, which I will link below. So if you want to learn more and understand, it's free. So the course was MS012, Explore the Microsoft Approach to AI. The key things that they talk about are they examine the Microsoft AI blueprint, examine how Microsoft is committed to the responsible AI. So we'll discuss more on that as we go more into the next videos that I make. So the next topic is user guidance. So Microsoft provides instructive prompts and source citations to foster responsible AI use. Here, there are some best places. One of the key things is build your own Copilot Center of Excellence. Here is a document, but I can list out this document and other links for you in the description below. The second thing is if you go here and you look at this, where we can find Copilot Prompting Toolkit. This is a great toolkit. So here you can see what is in the Copilot Prompting Toolkit, which I will link below as well. So hope these links and other things will help you understand a bit more into Microsoft Toolkit that provides for you as guidance. So the next topic is privacy and compliance. So I've divided this into a few questions that we can do it as a Q&A to keep the video short and also understand. One of the key questions was, does Microsoft use customer data to train its large language models? The short answer is no. Microsoft ensures this in different documents, but they ensure this through customer privacy by using customer data to not train their LLMs for other people. They're still used to train your own trained model. How does Microsoft ensure security for tenant data and prompts? So there is a different video that I'm thinking on, but here is a short answer. Tenant data and prompts are securely maintained and are not used for further training the LLMs, but are strictly guided within the tenant. Here is one example with an image of Power Automate's tenant policy. So I find this image giving an example of how the tenant data is stored. The next question is, what are the benefits of Copilot being integrated with Microsoft products in terms of security and compliance? This is one of the big benefits of Copilot. From established security, compliance, framework that already are part of Microsoft product are embedded into Copilot in a way, enhancing its overall trustworthy and reliability through the apps already. And also Microsoft Graph maintains its security privileges through your other existing apps. So the next topic is innovation with security. So while with new tech, any new tech introduces new security considerations, Microsoft has a good history in prioritizing privacy and security that mitigates these risks in a way. So let's hope that this new technology is coming with all of that. Given the documentation that we are seeing and the versions like version 2 and version 3 coming up already for risk and AI responsibilities, we can see that they're putting a lot of effort into this. So by implementing comprehensive Copilot security measures as well, there is a Copilot security, Microsoft Copilot security, that's a different product in itself. So Copilot is designed to secure AI assistants tailored to the business needs, ensuring that we have our enterprise data security remains within your own control, within your tenant, and is not compromised externally, even though we have extensibility for other places. So I hope this helps you understand where we are with Microsoft Copilot. I will dive deep in creating Microsoft Copilot with Microsoft Studio and other things. But mostly importantly, I would say thank you for watching. There are a lot of links in this video, so each one will help you understand more on your own. But thank you again for watching. Hope this video added some understanding of what is AI and different parts of AI. When you hear large language model and other things, you can understand what it meant. So thank you for watching again. Have a good day and see you guys soon. Bye.